Hi, this is Sim.
Hi, this is Chris.
I'm Tommy.
Hi, I'm Stefan Mayer.
And this is Team TBD.
Hello, my name is Chris, and I'm going to be showing you guys what we had to do for our first term project. For this project, our team was tasked with wiring up a stepper motor and then running to find the pull-in speed using a motor control chip. This was done by running the stepper motor at different step periods and applying a small load onto the step motor until we got the lowest step period to where the motor would barely turn. We then took that number and multiplied it by 2 to get our max pull-in speed. Finally, we ran the motor at 200 steps per revolution, 400 steps per revolution, 800 steps per revolution, 1600 steps per revolution, finally 3200 steps per revolution. This taught us how we can run the stepper motor at different settings according to our needs for the project. Here is a clip of our code for our project, and here is a clip of the motor running at 800 steps per revolution.
Hi everyone, Sim here, and for this term project, I'll be going over the second project we were assigned. For this assignment, we were tasked with driving a monorail using a stepper motor. We constructed a monorail and mounted a carriage on it, which we drove from one end to the other using QTI sensors and a pink sensor. Our monorail was remote controlled and the carriage had a sliding door.
Hello, I'm Tommy and I'll be going over our final project. For our final project, teams were tasked to create a wheeled, tetherless robot that would need to be able to move horizontally and vertically. Although achieving these basic specifications will only give enough points to pass. Extra marks are given for what our professor likes to call a wow factor. For Team TBD's wow factor, we decided on 3D printing an original robotic arm designed in SolidWorks, which would be controlled with a virtual controller we created through Wi-Fi.
Hi, I'm Stefan Mayer. I'm going to be talking to you about the final project we did in Mechatronics 320.
Alright, so this is the base of the turret that the professor gave us, and we were to mount the wheels and a top turret to it. We decided to advance the project by replacing the top turret as a robot arm, and this will allow us 3 degrees of freedom, and this arm can pick up things and we will be using servos. But in order for us to be able to control the arm, we need to use inverse kinematics. Now we learned inverse kinematics to calculate the angles needed for each servo to be at, given an X and Y designation.
We added another wow factor by being able to control the robot over Wi-Fi using a virtual remote.
So this is our Wi-Fi remote. The left joystick moves the robot. We can grab things, drop things. The right joystick and the slider moves the arm in the X, Y, and Z directions. We programmed the robot in C, and this is the code that takes in information wirelessly through the Wi-Fi remote control and moves the arm and moves the robot. And this is the robot in action.
Is that supposed to be the
No, wait. Alright.
Raise it.
I will.
Oh, I don't think that's...